Question number 8. So this can be done as a SUVAT question. There is constant acceleration, it tells us in the question. So we can write down that the initial velocity is 2I minus 3J. We know that the time taken is 2 seconds. We know that S is 7I minus 10J. And we are asked to work out A. So with this information, I can use S equals UT, all vectors remember, minus a half a t squared. So if I substitute in the values that I've got, I'll use column vectors. I think it's easier to see using columns. 7 minus 10 is equal to UT, which is 2 times 2 minus 3. Plus minus a half a t squared. Well, a half of t squared is 2, so that's 2a. And so taking this equation, therefore 2a is equal to 7 minus 10, take away 4 minus 6. So 2a is 3 minus 4, and then therefore a is 3 over 2 and minus 2, and if we do the magnitude of a, that's the square root of 3 over 2 squared plus minus 2 squared, and that comes to 2.5 meters per second squared. And that's what it asked us to show. Now we have further development, and for part B, at A, we know that V is equal to U plus AT, and therefore V is 2 minus 3 plus a half of 3 minus 4, which is A, isn't it, of course, times 2 times T. So therefore V is equal to 5 minus 7. So that's the velocity at A. So for section AB, our initial velocity is now 5 minus 7. The acceleration is 4 and 8.8, as we're told. And what we know is that when it's traveling in a northeasterly direction, the components of the final velocity will be equal. So we have that V, the final velocity, V equals U plus AT. So that's 5 minus 7 plus T times the acceleration of 4 and 8.8. And for northeast, it must be that 5 plus 4t is equal to minus 7 plus 8.8t. And if we work through that, we get 12 is 4.8t. Therefore, t is 2.5 seconds.